Hey guys, so this is the last lesson of trigonometric identities and equations. It's probably my most favorite lesson to talk about too, because really it takes the entire unit of solving equations. You have to kind of remember that we started this unit saying, okay, how do we solve equations? What does that look like? And then we kind of just stopped doing that. We went into identities and we looked at simplifying identities and then proving identities. This now takes those two concepts and kind of marries them back together. So it's a great last lesson of trig. So what we're going to do essentially is we're going back to solving equations. The difference is now you're going to have equations where you have to deal with identities as well. Okay. So as we go about doing this, just a couple things to keep in mind. First of all, factoring is your friend. Always, always, always look for what can I factor. Something important happens when you take the square root. Be super careful of this. When you are taking the square root of both sides, it's going to be plus or minus. If you don't have plus or minus, you just lost half of your answer. So you have to be super careful of that. When you're factoring a trinomial, one side better equals 0. Unfortunately, I see sometimes students trying to go, they'll have like actually let me write that down so you see it. If you have something like 2 sine squared theta minus sine squared, let's go minus sine theta equals 1. And they'll be like, hey, I can take sine out of both of these. No, you can't. You can't do that until everything is on one side and it equals 0. So the first thing you'd have to do is minus 1 from that, then try and factor the trinomial that you have left there. Okay, so just be careful of that. Watch your domain. Now, in all of these questions, you're going to have restrictive domains. So you're going to be like going from negative pi to pi, or you're going to go from negative 540 degrees to 720 degrees, whatever it is. Do every question like you're going from 0 to 2 pi. Find all those answers first, because every other answer you're doing is going to be coterminal to that. So always ignore that restrictive domain until the end, okay? Figure out all the answers between 0 and 2 pi, then look at your domain and decide, okay, what's actually allowed in here and what coterminal ones can I now also throw into my answer set. Never divide out functions. If you divide them out, that's where the factoring comes in, right? If you divide them out, you've just lost half your solutions. Always find restrictions, even if you're not asked to, because some of those restrictions could end up causing you to find extraneous solutions, and you can't have those as your solution set if you're extraneous. It's important that you find extraneous solutions and then somehow in your work communicate that they are extraneous. So either you're going to cross them off or you're going to write extraneous or whatever you do. But it's important that that's communicated to us. Otherwise, we wonder, hey, did they actually even know that this was mathematically a solution and it didn't work? Or did they just skip it? So just make sure that you're communicating everything super clearly. Okay, so for these first couple of questions here, the directions say solve the following equation algebraically in the specified domain. Leave your answer as exact value. Just a quick point on this. We're kind of being nice to you here by saying leave your answer as exact value. The general rule on any diploma that you would write would be if rounding instructions are not given to you, then you have to answer an exact value. Okay, so if they don't say round to the nearest hundredth, they're expecting that that answer is going to be a non-rounded version. Okay, so just something to keep in mind. Okay, so first question, cos of 2 theta plus cos theta equals 0. Now, let's talk NPVs first. Okay, for this guy, there is none. There's no division of 0 here that is possible, but I want you to get in the habit of the very first thing you do, always check for those NPVs. Okay, now the next thing you do is you try and start simplifying the equation. Cos of 2 theta, you don't ever want to deal with a double angle. So the very first thing you want to do with the double angle is you want to substitute. So take a look at your formula sheet. Everybody's got that right beside them, I'm hoping. There are 3, we talked about this yesterday. There are 3 different possibilities for cos of 2 theta. One of them is just super nicer than the others. The one that I'm going to use is I'm going to use the 2 cos squared theta minus 1. The reason I'm doing that is because when I do that substitution, I'm not introducing a different trigonometric function. I'll still be looking at an equation that only involves cos, and that's going to allow me the chance to probably factor this, okay? So I'm gonna substitute my my cos of 2 theta with 2 cos squared theta minus 1, and then I still have the plus cos theta there. Now, this is just a quadratic. I'm just going to factor that. Let's rearrange the order so it looks more like the friendly quadratic I've come to know and love. Now, again, just like we were doing with other solving trigonometric equations at the beginning of this unit, if this is a little intimidating to you, make a substitution. Say, let cos theta equal a, change this to 2a squared plus a minus 1, and then factor that, okay? I'm not going to do that, but if you do that, just make sure you have it said somewhere in your notes, let cos theta equal a. Otherwise, it's not valid what you're doing, okay? So I'm just going to factor this. However you factor is totally fine. In these notes that I'm going to walk you through, I'm usually going to factor using decomposition because I think that's what most of you are familiar with. But if you do it another way and you get the right answer, totally fine. So I'm looking for two numbers that multiply together to give you -2, add together to give you 1. Those two numbers happen to be 2 and -1. So I have broken my middle guy down into 2 cos theta minus cos theta. Factor the front 2, I can take out a 2 cos theta. Factor the back 2, I can take out a -1. So then I have cos theta plus 1 as a common factor. So in factored form, I end up with 2 cos theta minus 1 times cos theta plus 1. Now, this is the zero product principle. So either this fella here equals 0 or this fella here equals 0. So I branch this off into 2 different statements and I just solve each statement. So cos of theta equals 1/2. That's taking this guy and setting it equal to 0. And then I just brought my 1 over and divided by 2. And cos of theta equals -1. Okay, so now we go back to my handy dandy unit circle. Where does cos of theta equal 1/2? Well, I have to be in quadrants 1 and in quadrant 4. And that'd be pi over 3 and 5 pi over 3. Where does cos of theta equal -1? Remember that cos is your x value, so an x value of -1 would be at pi. So right now, going from 0 to 2 pi, remember I'm ignoring the domain, 0 to 2 pi, my answers would be these 3. I'd have pi over 3, pi, and 5 pi over 3. I now take a look at the domain. The domain is from 0 to 2 pi, so those are my answers, and I just state those in a solution set. See? Easy peasy. 1 down, 1800 to go. It's all good. Okay, number 2. Cos of 2 theta times 4 sine squared theta minus 3. Again, get into the habit of asking yourself as the very first question, is there any NPVs I have to think about? There is no division here, so there's no possibility to have a 0 on the bottom of a fraction, so there's no NPVs. Common mistake I see kids make with something like this is they immediately get this tunnel vision and they say, okay, that cos 2 theta has to get multiplied into the 4 sine squared and into the -3. No, it doesn't, because our ultimate goal here is to have it in factored form. This is already in factored form. So I essentially just have the zero product principle and I can go right into each factor equaling 0 and solving. Now, before I do that, I probably want to deal with this cos of 2 theta. I want to make some sort of a substitution. Again, there are 3 options available to me. I chose the 1 minus 2 sine squared theta, partly just so I could think of sine, but because, so that it was just sine in this whole equation. Because this was already in factored form, though, it would have been just as easy to use the 2 cos squared theta minus 1. The only thing I wouldn't have maybe done was the cos squared theta minus sine squared theta, because you don't want to introduce 2 different trigonometric ratios in the same factor. You can, it is still solvable. It just requires a little bit more thought. So I would stick with either switching it to the one I've got here or the 2 cos squared theta minus 1. Okay, so this is the zero product principle now. Either this guy equals 0 or this guy equals 0. So I'm going to split this off into 2 separate statements. If this guy equals 0, I'd be looking at bringing the 1 over and dividing by 2. So sine squared theta will equal 1/2. And then over on the other side, I'd add 3 to both sides and divide by 4. So I've got sine squared theta equals 3 over 4. Now for both of these, the next step is to take the square root. So here's my friendly warning one more time. When you take the square root, it could be plus or minus. So this guy here, theta is going to, or sine of theta is going to be plus or minus root 2 over 2. And then over here, we're going to get plus or minus root 3 over 2. Okay. Let's solve this guy first though. So plus or minus root 2 over 2, theta is every pi over 4 angle in all 4 quadrants. So that's pi over 4, 3 pi over 4, 7 pi over 4. Sorry, I skipped 5 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Over here, we end up with plus or minus 3 over 2, like I had already said. Okay, so that's going to be up at the pi over 3s. And again, that would be in every quadrant. So that ends up being pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now that I have all of those solutions, I take a look at where I was allowed to be. I'm allowed to be from 0 to 2 pi. So those are, in fact, all of my solutions. It's a good idea when you do your solution set, write them in order, not just this guy and this guy, but write them in order from smallest to largest. Okay, so my solution set is pi over 4, pi over 3, and you can use your unit circle to help you see which one comes first, right? 2 pi over 3, 3 pi over 4, 5 pi over 4, 4 pi over 3, 5 pi over 3, and 7 pi over 4. Good. Okay, next guy, we're looking at 2 tan of theta cos squared theta plus sine of theta tan of theta minus 2 tan of theta equals 0. Now, there's also a wonky domain going on here. Again, I'm going to ignore that for a few minutes. What to do here? Well, what do I see? Well, the first thing I want to ask myself is NPVs. Tan is involved here. Tan does have an NPV. Cos of theta can't be 0, and that ends up being at theta equals pi over 2 plus pi n, where n is a member of the integers. So I want to state that first. When I go to get all my solutions, I always want to get all my solutions and then go back and check that NPV and make sure that none of my solutions are those NPVs. Okay, next, I want to start thinking about factoring. I see that all 3 of these terms have tan of theta in them. So one thing I'm going to do right away is just factor the tan of theta out. Okay, that makes it, actually right away, that makes it very less intimidating looking. Okay, I just have tan of theta as one of my factors. Now, let's deal with what's on the inside there for a second. I don't really want a factor that involves cos squared theta and sine theta. There's not really a whole lot I can do with that. So let's take my cos squared theta and let's change that guy to sine. I can do that using the Pythagorean identity. Cos squared theta is going to be 1 minus sine squared theta. Okay, now it's important that you realize there's a 2 in front of there. So when you go to do that substitution, you just need to make sure that it goes to bracket 1 minus sine squared theta. Okay, so now I'm going to work on just cleaning up this inside here. This is going to be a 2. This is going to be a negative 2 sine squared theta. And then I want to start rearranging things so that it has, it's in the proper descending degree order. So I've got 2 minus 2, that's actually 0. And so I'm going to be left with negative 2 sine squared theta plus sine theta. Okay, so now I want to factor. Sine theta is common to both of those. So I took out the sine theta, and then that would leave me with negative 2 sine theta plus 1. Okay, so I've simplified this into all of the factors, which means now I'm back to the 0 product principle. Remember, I couldn't do any of this if it didn't equal 0 here. Big thing to remember. It does equal 0, so I'm good to go. So this is the 0 product principle. It's just that now I break it down into 3 different statements. Either tan of theta equals 0, or sine of theta equals 0, or sine of theta. Remember, if this equals 0, I'm going to bring the 1 over. It'll be negative 1. Then I divide by negative 2. So that would end up being sine of theta equals a half. Okay, where does tan of theta equal 0? For that guy, I would be at 0 pi and 2 pi. Where does sine of theta equal 0? Actually in the exact same spot, so there's no additional solutions yet for this guy. And then where does sine of theta equal a half? I'd be looking at pi over 6 and 5 pi over 6, quadrant 1 and quadrant 2 there. Okay, so those are all my answers. Now I have to think about, okay, I have to think about the wonky domain. Now, I think the easiest way to deal with this wonky domain is just to think about this from a number line perspective, okay? So here's a big old number line. I know that my answers right now are 0, I got pi, I got 2 pi, I got pi over 6, and I got 5 pi over 6. I squished that up a bit, but okay? Those are all my answers that I've got right now. Then I'm told, hey, that's super, but my window can actually go, ugh, that's a really bad marker. My window can actually go, say, from here at negative pi all the way over to here at 3 pi. So now I'm thinking, okay, is there other stuff, is there other solutions here that I can add into this? And they're always going to be coterminal to this guy. So 0, if I subtract 2 pi, that's going to get negative 2 pi. Well, that's too far. That's outside my window. Pi over 6, if I subtract 2 pi, that's going to give me negative 5 pi over 6, which is just a little too far. Okay. Pi over 6, subtract, sorry, I said that wrong actually. That would be 12 pi over 6, right? Because 12 pi over 6 is 2. So that would give me actually negative 11 pi over 6. Okay, not negative 5 pi over 6. Negative 5 pi over 6 would actually have been okay, right? But this guy gives me negative 11 pi over 6, so too far. 5 pi over 6, subtract 12 pi over 6 would give me negative 7 pi over 6. So again, too far. That would just be on the other edge of here. And then 2 pi, subtract 2 pi gives me 0. So there's actually no negatives that I can throw into here, okay? Because when I got all the coterminal angles, they were still beyond this section here. Here though, if I add, well, if I add 2 pi to 0, that's just 2 pi and I already have that guy. Pi over 6 plus 12 pi over 6 will give me 13 pi over 6, so that's a viable solution. 5 pi over 6 plus 12 pi over 6 will give me 17 pi over 6. Also a viable solution because you got to remember that 3 pi would be 18 pi over 6. So 17 pi over 6 is just within that window, okay? I'm hoping that that makes sense as to how I'm doing it. The easiest way to do that is to just write it out like that, okay? So my solution set, I've got negative pi, 0, pi over 6, 5 pi over 6, pi, 2 pi, 13 pi over 6, and 17 pi over 6, okay? I don't think I mentioned negative pi. Sorry, that would have been coterminal to pi. When I subtract negative 2 pi from pi, I'd get to negative pi. That's where negative pi came from, okay? So that's my solution set for that guy. So yes, this one got messier. There's a lot more thought involved, but it's a bunch of little thoughts, and every one of those little thoughts you have dealt with before, okay? So it's not new, it's just a lot to think about all at once. Okay, good. Next guy here, I've got sine of 2 theta times the tan squared theta minus 1. Now, again, this is already in factored form, so I don't need to multiply that sine of 2 theta. I probably do want to change the sine of 2 theta to be 2 sine of theta cos of theta. If you look at your formula sheet, that's the identity for double angles. Remember, you never want to deal with a double angle. Always substitute the double angle out with whatever trigonometric identity you have on your formula sheet. Let's talk about NPVs first though. So I do have tan here, so I can't be 90 degrees and every multiple of 180 after 90. So I'm speaking in degrees here because my window is in degrees. You always want to speak in whatever language you were given here. Okay, now I'm going to swap my sine of 2 theta out to be 2 sine theta cos theta. And essentially, I'm right back to the zero product principle because I've got, like, the 2 is inconsequential here. I've got this factor here, I've got this factor here, and I've got this factor here. So either sine of theta can't be 0, or sorry, either sine of theta is 0, or cos of theta is 0, or tan squared of theta is 1. So those are my 3 statements that I now need to dive into. So if sine of theta is 0, that's going to be 0, 0, 180, and 360. If cos of theta is 0, that's 90 and 270. And then if tan of theta, I took this right away to taking the square root of it. So that's why it says plus or minus 1. Remember, it was tan squared. So tan squared theta equals -1, which means tan of theta equals plus or minus 1. Okay, and then that is all my 45 degrees in every quadrant. So that'd be 45, 135, 225, and 315. Okay, now I look at all this and I have to start thinking about two things. I have to think, okay, what was my original domain? My original domain was 0 to 360. So all of these fit. And then I have to think about my NPVs. Hey, none of that fits because those are actually NPVs. So my answer is this guy with this guy. So I'm going to write that as a solution set in order from smallest to largest. Okay. All right, great job, guys. Next up, this was actually a released item from a diploma once upon a time. And it's a find the error question. The steps shown below here, or below, were used to determine the complete solution set to the equation 3 sine squared x plus cos squared x plus 5 sine x minus 4 equals 0. I would love it. Oh yeah, and theta is from 0 to 2 pi. I would love it if you paused me at this stage of the game. If you haven't been pausing me is good because I want you guys to try these things on your own. This is a great one where I want you to pause me and see if you can come up with a conclusion. Now, if you paused me, you might be frustrated at this stage of the game because you've gone through this over and over and over again and you're like, maybe you just haven't found what's wrong. Everything they've done is actually allowable. And this is a great conversation to have when it comes to finding the error questions. I know often kids got thrown by this step 1 here because they're like, well, why would you do that? Why would you break your 3 sine squared into 2 sine squared x plus sine squared x? Well, that's how this person thought, okay? Maybe that's not how you would have thought about it, but it's allowed. When you're trying to find an error, it's not about the person didn't do it the way you would want it done. It's whether they actually made a mathematical error. There is no mathematical error here. Breaking 3 into 2 plus 1 is totally cool. We do that in composition all the time. Now, if you're wondering why the student did that, it's because then they looked at this guy, which is sine squared plus cos squared, and they changed that to a 1. That's why they chose to do it that way. Okay, so everything they've done here is actually fine so far. Then they got down to a quadratic right here. They correctly did this. They correctly factored, okay? I've had students say, oh, the mistake must happen at step 4 because they didn't show us factoring work. Remember, this was a diploma question and there's a bunch of different ways to factor. They purposely didn't show you factoring work because they didn't want a person who doesn't use decomposition to then say decomposition was wrong or vice versa, okay? Then they went to the zero product principle. That is correct. And pi over 6 is actually a correct solution. So then we're like, well, what is the problem? The problem, if you haven't found it yet, is that pi over 6 is not the only solution. If you are allowed to go from 0 to 2 pi, that means you can be in any of the 4 quadrants. There are 2 solutions, pi over 6 and 5 pi over 6. Okay, so the error was in step 6, and the error itself was that that solution is not complete. They're missing the 5 pi over 6. Isn't that fun? Okay, the values of x that satisfy the equation 2 sine squared x equals negative sine x for the interval negative pi to pi. Now take note of those brackets as well. I can be negative pi, I can't be pi. Okay, so this ends up just being a quadratic. I'm going to bring my negative sine x over so that it equals 0, and that allows me to factor. There are no NPVs. We'll just have that conversation right quick. There are no NPVs here because there's no fraction. I can then factor out a sine of x. That will leave me with sine of x times 2 sine of x plus 1. Sine of x can be 0, or sine of x can be negative a half. Sine of x is 0 at 0, pi, and 2 pi. Sine of x is negative a half. That would be in quadrant 3 and 4. So that would be 7 pi over 6 and 11 pi over 6. Okay. Now that I've got all my answers between 0 and 2 pi, I take a look at that restrictive domain. So the 11 pi over 6, the 7 pi over 6, the 2 pi, and the pi are all too big. Every one of these guys here are all too big. The only thing I can take from there is 0. But I can also look for coterminal angles. So if I subtract 2 pi from pi, I'll get negative pi. If I subtract 2 pi from 2 pi, I'll get 0, and I've already got that guy. If I subtract 2 pi, remember 2 pi is 12 pi over 6. So if I subtract 2 pi from 7 pi over 6, 7 minus 12 is negative 5. Sorry, I'm writing with a mouse, but I just want to, so it'd be negative 5 pi over 6. You guys can all laugh at my mouse writing abilities. And if I subtract 2 pi from 11 pi over 6, that'll give me negative 1 pi over 6. Okay, so now my solutions are, I've got negative pi, I got negative 5 pi over 6, negative pi over 6, and 0. So it looks like D to me. Okay, awesome. Now, that is actually the end of our note, but I was having so much fun. I'm going to do 2 of your homework questions with you. You know, I'm just feeling a little generous, and these particular 2 often cause confusion, so I want to walk you through with them. So if you can take a look at your homework, I'm going to do practice question 2 with you, which is 2 sine to the 4 theta plus cos to the 4 theta equals 1, and we're going to go from negative pi to pi. This is a mess, but remember, everything with math, there's always beauty in the mess. Okay, so what to do? Well, I'm going to divide both sides by 2 to get rid of this 2, so that's going to be a 1/2 over here. Then I want to, essentially, I want to work on trying to get all of these trigonometric functions to be the same. So how I'm going to handle that, let's talk NPVs first. There isn't any, but it's a conversation you want to have with yourself. So I'm going to switch my sine to the 4 theta to sine squared theta. Okay, so what I've done there is I've divided both sides by 2. That's where the 1/2 came from. And I switched my sine to the 4 to be sine squared times sine squared. Well, why did I do that? Because sine squared I know is 1 minus cos squared. So I can switch this to be 1 minus cos squared theta times 1 minus cos squared theta. And now I've got the beginnings of a quadratic here where it just involves cos. Okay, so this is where it gets a little messy though, because I have to FOIL this. So I've got 1 times 1, I've got negative cos squared, I've got negative cos squared, and I've got cos to the 4. So all together there, that'll be 1 minus 2 cos squared theta plus cos to the 4 plus cos to the 4. Now, I want to work on cleaning this up a bit. I've got 2 cos to the 4s here, so that'll be 2 cos 4, or cos to the 4 theta. I also want this to equal 0, so I need to subtract 1/2 from both sides. Don't let this confuse you. If I subtract 1/2 from 1, I end up with 1/2. Okay, 1 minus 1/2 is 1/2. Okay, so when you see this next guy here, I've had kids look at this and say, oh, well, you didn't change this 1/2 to a negative. Well, yes, I did. It's just that there's also a 1 there. Okay, so cleaned up a bit, I've got 2 cos to the 4 theta minus 2 cos squared theta plus 1/2 equals 0. Now, in order to factor this, I want to get rid of the fraction, so I'm going to multiply everything by 2. And now I'm going to go ahead and factor. So I'm looking for 2 numbers that multiply together to give you a 4, add together to give you negative 4. That would be negative 2 and negative 2. Okay, so I took my middle term and I'm just walking you through decomposition. I took my middle term and I separated it down into negative 2 cos squared, negative 2 cos squared. Factor the front 2, I can take out a 2 cos squared. On the back, I just take out a negative 1. And that leaves me with 2 cos squared minus 1 in the brackets. So that's now a common factor. So the factored version of this is 2 cos squared theta minus 1. Now I go to solve that. I don't have to solve them both, they're the same thing. So cos squared theta equals 1/2, which means cos theta will equal plus or minus root 2. So now I'm looking for where does cos theta equal plus or minus root 2. So that's going to be every pi over 4. So I'm looking at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, now I'm going to go back up here and think about my domain. I'm allowed to go from negative pi to pi. So right off the bat, these guys here are, oh, that's not what I thought I was showing you. Those guys there are too large, but I'm going to look for coterminal angles by taking those and subtracting 2 pi from them. So now that I'm at fraction over 4, 2 pi would be represented as 8 pi over 4. So a coterminal angle to 5 pi over 4, 5 pi over 4 minus 8 pi over 4 is negative 3 pi over 4, and 7 pi over 4 minus 8 pi over 4 would be negative pi over 4. Okay, so my solutions end up being negative 3 pi over 4, negative pi over 4, pi over 4, and 3 pi over 4. So that is question 2. All right, now if you thought that guy was fun, take a look. I'm just going to clear my drawings here. Take a look at, this is question 7 in your book. And I'm going to tell you right off the bat, I don't think we left you enough room for question 7. So you might want to pause me and get a piece of paper if you want to do this question justice. All right, so we're going from negative 180 to 180. Okay, well, let's talk about MPVs first. Secant is 1 over what? Okay, secant is 1 over cos, but cosecant is 1 over sine. So either way, sine can't be 0. Cos can't be 0, which means my NPVs, we're looking at theta equals 90 degrees n, where n is a member of the integers. All right, so I'm going to switch all this to sine and cosine. So I went secant squared theta is 1 over cos squared theta. Cos squared theta is negative 1 or 1 over sine squared theta, and then I'm just subtracting there. Then I switch this to division for a second. So I've got secant squared theta, which is 1 over cos squared theta, divide by cosecant squared theta, which is 1 over sine squared theta. Now, let's just deal with this first. 1 over cos squared divided by 1 over sine squared would be 1 over cos squared times sine squared. So it just ends up being a sine squared on the top. Now, let's get rid of the fractions here. So we're going to multiply everything by cos squared theta, sine squared theta. If I multiply this guy by cos squared theta, sine squared theta, I'm left with just sine squared theta, because my cos squared thetas will divide each other out. This will just leave me with cos squared theta. This will leave me with sine to the 4 theta, because my cos squareds will divide each other out, but I'm left with sine squared times sine squared. So that's where this equation comes from. Sine squared theta minus cos squared theta equals sine to the 4 theta. Now, I'm hoping you feel good about what your next step would be. I'm going to take my cos squared theta and switch it to 1 minus sine squared theta. I'm going to use that Pythagorean identity. Remember that that negative will apply to both here. So this is going to end up being negative 1 and plus sine squared theta. Now I'm going to bring everything over to one side and set it equal to 0. This is 2 sine squared theta. This is a negative 1, but I'm going to bring them over here so that it equals 0. So that's going to end up with sine to the 4 theta minus 2 sine squared theta and plus 1. Now that it equals 0, I'm going to try and factor it, looking for 2 numbers that multiply together to give you 1, add together to give you negative 2. That would be negative 1 and negative 1. So I'm looking at sine theta equals, or sorry, sine squared theta equals 1, which means sine of theta equals plus or minus 1. Where does sine of theta equal plus or minus 1? I'm looking at 90 and 270. Then I have to do 2 things. I have to look at my domain, and I have to look at my NPVs. And as soon as I look at my NPVs, 90 and 270, and every multiple of 90 and 270 after that is an NPV. So the only solutions I have found are extraneous. and so there are no solutions. Kind of a mean one, which is why I thought I might do that with you. Okay, so I hope this has been helpful. That's what you're doing for your last note here. Your page numbers have been shown here for you. And as always, don't be a stranger. If you have questions, make sure you're asking. Okay, good job, guys. Have fun and take care.